welcome to Academia Tuitions. And today we're going to talk about atoms and elements and compounds and molecules and, just all of that sort of stuff. I mean, I tried to, I tried to make it really fancy, but obviously there wasn't enough space. Yeah, can you just zoom in? Yeah, thanks for that. You can just see what this is going to be about. Sorry everyone, but now you know what it's about. Okay, cool. Just appreciate the fanciness. Anyway, so what is an atom? The concept of atoms actually came from the ancient Greeks a long time ago. They believed that everything around us was actually made up of 4 elements. They thought that they were air, fire, water, and earth, and that's it. But obviously now we know, that things are actually much more complicated than this. So in the 1800s, a lovely little chap called John Dalton, he developed his theory. And in that theory, he brought back the idea of atoms. This is his proposition. So he said that everything is made up of tiny particles called atoms. And he believed that atoms can't be destroyed. You can't break them apart. And he obviously knew that, atoms of the same type, they can combine together because that's just what atoms like to do. They like to just make things much more complicated. So you guys have a lot more to learn about. So atoms, they can form elements because basically substances that are made up of just one type of atom are called element. And if you have different types of atoms, well, Dalton knew that they can form a compound. So a compound is a substance that's made up of 2 or more different type of atom, but they have to be chemically combined. Okay, this is the important bit, chemically combined. Now, if a substance is made up of 2 or more type of atom that isn't chemically combined, that's called a mixture. So, for example, a mixture can be sand and water. You can actually take sand out of water. Whereas compounds is something like salt and water. You can't actually get rid of salt and water that easily. You can eventually, but it's quite difficult. And molecules is what makes up an element. So sometimes, 2 or more of the same type of atom, they can become chemically combined, and that's what actually forms the solid blocks basically of an element. Okay, so now that we've talked about, Dalton's theory, I'm just going to highlight something that Dalton believed in, and he believed that atoms can't be broken down and they're, you can't destroy an atom. Well, he was wrong, and basically later in the 1800s, a guy called J.J. Thomson, he discovered the electrons, and this is basically the substructure of an atom. It looks quite complicated, don't get scared. I did the first time I saw this, literally. But anyway, so there's a subatomic particle called electron, and they move around in these paths. And these paths are called shells. And inside, you can see that there's quite a concentrated mass of neutrons and protons. Neutrons, protons, and electrons. These are subatomic particles. Particles that are inside the atom. Okay, and they can actually have relative charges and relative masses. So let's talk about the neutron. So it has a relative mass of 0. A relative charge of 0. So basically it's neutral. It doesn't have a charge. It has a relative mass of 1. So it's 1 unit compared to everything else. Protons have a relative charge of +1. So they're positive. They have a mass of 1 unit. Electrons are a bit weird compared to protons and neutrons because they have a -1 negative charge, so they're actually negatively charged. They also have a mass of 1 over 1,800. You don't really have to know this figure, this fraction, but what you need to know is that, electrons, they don't have a relative charge of 0, but they don't either have a relative charge of 1. It's not like they're heavy like the protons and neutrons, but they're not exactly not even there. Like they are very, very small, but still there. Okay. So this is actually, you know, the model that we think of nowadays. But because this model, you know, it has gone through like a few, like basically a few tries, as we must say. So John Dalton, he believed that obviously you can't break up an atom. J.J. Thomson, when he discovered the electrons, well, he thought that, you know, atoms look like this. So ignore that for a second. But this is what he thought they looked like. There are a few positive charges, you know, here and there, and then a few negative charges, just like sprinkled around in this spherical mass. So he looked at this and he was like, that looks like my Christmas pudding, you know. So he called it the plum pudding model. I honestly think he was just really hungry that day, and I love Christmas pudding, so that's probably why he called it that. But, you know, here we have something to learn about his model. And basically, we've talked about how, you know, these theories, well, his J.J. Thomson's theory was eventually scrapped because we discovered, well, there's also a thing called neutrons as well. We now have to talk about elements, because atoms, they can combine to form elements. So at John Dalton's time, which is the 1800s, John Dalton, he discovered the fact that basically there are a few elements in the world today. So at his time, there were around 20 to 25 different types of elements. And he thought, let's just come up with a few like decoding like alphabet for it. So what he thought was that let's call hydrogen, well, a circle with a dot in it, and carbon just a fully coloured black circle, and sulfur can be a circle with a cross in it. Obviously there are 25 different elements at his time, and that was complicated enough. So now we know that there are actually 120 something elements in the world today. Some of them are naturally found and some of them are man-made. So obviously that's like mind-blowing. You can't have that many different symbols for it. So now we just have quite a simple abbreviation for all the elements. So these are some of the common elements that we have today. So you don't have to know these, like you don't have to learn these, but if it's just much more like convenient for you to find these elements if you just like know some of the common ones. So for example, copper is not CO, it's Cu. So I see you, copper. That's how you could remember it. Sulfur is just S. Hg is mercury. This is quite a, well, complicated one that you kind of just have to learn if you want to. C is just for carbon. H is for hydrogen. O is for oxygen. Au is for gold. How I remember it is, Au, give me your gold. But you can have your own little, you know, rhyme or way of learning things. Ag is for silver. So on me, silver always looks good. So I'm always like, silver is my G. Iodine is just I. These are some of the common elements. Obviously, there are like 120 of these. You don't have to know every single symbol, but it's just, you know, appreciate the fact that we don't have circles and all that going on over there like we did over there. Imagine how life would be if it was that. That would be so complicated. To finish off with, I'm just going to give you a quick little practical example. So let's have a look at this keychain here. Okay, so yeah, don't judge. It's my keychain from Next. We know that this is an element. Now, why do I think this or know this? Well, basically, can you see across the sides, there's a bit of rusting going on here. It's that yellowy kind of color around the ends. Now, there's only one type of basically metal that does that sort of rusting, and that's iron. If iron is chemically combined to a different type of atom, So basically, if iron is in a compound, it doesn't rust. So we know that this must be an element because of the rusting that's going on here. This is a type of element. Now, I'm going to show you a compound. So this is a piece of acrylic. This is another keychain from my keychains. And you know that acrylic is actually plastic. So plastic is basically a mixture, and like it has mixtures and it has like compounds, different types of compounds. So we know that this is not an element. It's either, you know, a bit of mixture or it's a bit of compound. So that's a wrap, guys. That's the whole video on atoms and molecules and blah blah blah. If you guys didn't understand anything or you wanted more clarification, please let me know in the comments below and I will reply to all your concerns. If you didn't like the video, please let me know. If you liked the video, let me know. Any constructive feedback from you guys will be heavily appreciated. This is actually my first time making a video. Obviously, like the video, subscribe to my channel, and yeah, see you later. Happy revising!